in the old days, old mineral oil and the old CFC refrigerants they were very compatible. They loved each other. As we went into different refrigerants and went into different oils, that compatibility had to be engineered in and had to be kind of taken up. But it's that temperature of that oil is just really huge, because if it starts to degrade, starts to get above a given point, it's going to create some issues. You're going to start, the oil's going to break down. It literally will cake or bake sometimes in some surfaces of the compressor we see in teardowns.
And welcome everyone to our second session on compressors. We're diving into semi-hermetics. Hopefully you were able to watch the scroll session. There's just so much knowledge. Lots of great questions came in. And it's what it is, just investing in yourself. This is what it's all about. Taking the time to be here. You guys are putting the work in, and we really appreciate seeing that. The more time you spend on learning from different people, the more you're going to grow. Bob, how you doing, brother?
Good, pal. How about yourself?
So well. So we're going to be diving into semi-hermetics, and this is really where you started. You started with semi-hermetics. There was no scrolls even invented at that point. You're diving into the semi-hermetics, and you've seen the generation changes over the years to what they are today. Let's talk a little bit about the history, and then we're just going to dive right into it.
Cylinders and pistons and rings and valves were the king for ever and ever and ever. Semi-hermetic compressors were well built back in the day. They were meant to be a serviceable compressor. When they started putting oil pumps on them, you could change an oil pump. You could get in there and change those valve plates or valves in some cases, depending on the manufacturer. It was meant to be a serviceable type component. You could change the oil, you could monitor your oil levels, your oil pressures with oil pumps. It really was the king of the road for years and years. Air-cooled was probably big at first, and then eventually refrigerant cooled came in. You still see a few air-cooleds, I believe, smaller condensing units, handful of those things. A bit of a different story between an air-cooled compressor and a refrigerant-cooled compressor, without a question. You don't think about, we think about flood back being, slugging sometimes in some cases. With refrigerant-cooled, not always necessarily true to an extent, but in air-cooled for certain can definitely be it's a direct path right into that. As the suction gas comes back in that head, it's right into the cylinder from that point. So air-cooled had its definite home. Air-cooled worked good in cooler ambient temperatures to an extent. You had to, if there was any kind of auxiliary fan or anything like that, typically that was shut off. But, you needed amount of air movement over that compressor. I want to say something like 400 CFM or 450. The exact number kind of is back somewhere in the memory stick, but you needed to move air across the body of that compressor, and it was very, very important. As they started making larger compressors, air-cooled wasn't feasible. Yeah. And you wanted to get into, 20,000 BTUs or 25,000 or 50,000 or 100,000, it just wasn't feasible to keep it at being an air-cooled. So refrigerant-cooled was adapted by a bunch of the manufacturers. Copeland, Tecumseh, Carlisle, literally, they all had the same ideas to an extent, and everybody had a little bit of idea how to do it. And that's of course, that's what makes our industry great. If we were all exactly alike, we'd be in real trouble, I think. But kind of as we move into the larger compressors, the reed style valves were very, very prevalent to an extent. I know Carlisle and Copeland both went to different type designs. Copeland called it the discus valve, and that was somewhere about the early 90s or so. And that kind of changed the dynamic a little bit too, because they were able to gain a lot more volumetric efficiency, better flow in and out of the cylinders. And so every compressor manufacturer is always making something better. Each year, maybe it's a part, or maybe it's an engineering or design change, but there's always going to be some improvement. And though we were able to increase volumetric efficiency with discus valve design and applications, it still wasn't anywhere near, as the scroll was developed eventually, it wasn't anywhere near that. And so like we talked about yesterday, rotary technologies were taking over more and more. But there's still tons of the larger reciprocating compressors out there, and we can call them reciprocating compressors. That's what I grew up calling them. Copeland's name was brand name was Copeland, and What was Spitzer's? Do they have a special name,
I
Trev?
think it was always Bitzer. There could have been a different name, but I'm pretty sure it
Yeah,
was just
yeah,
always
that's
Bitzer.
but that's kind of a branding thing and stuff like that. But they're still the king of the road, as far as I'm concerned, with some of this stuff. And even in the new CO2 compressors, they're bolt together. Now there might be a few more bolts, right, Trev?
Yeah, yeah,
Without
bigger.
a question. But
Yeah, bigger.
that's that serviceable aspect really is important for the true refrigeration mechanic, as far as I'm concerned. And he feels good when he can get that done. Those welded products are mystery machines when you're dealing with a lot of that stuff, because you just other than being able to relate what it is and real experience, nothing like being able to take that, also isolate the compressor and take that head off and see what's going on at the valve plate, see what's going on in the cylinders, see if one pushes up farther or whatever it may be. It's just so much to learn from those, and that's what I actually was the key to the cost class, as we went over the operation of semi-hermetic compressors, air cooled, refrigerant cooled. And then at that point there, the idea was to start dropping. We went over the operation. Then the idea was to talk about those failures, which we're going to touch on the next session. But you hit that, and then you had your tear down. And day 3 of the tear down was always the highlight of every class that we ever did. And I think we have to explain to everybody that, because the wholesalers will get these compressors back. Some of them would be returned under warranty. Some would be returned just because they were failed and had to replace. And sometimes they abandoned a piece of equipment and they were just core compressors. So you have to kind of let everybody know that we didn't really know what was wrong with any of these. And, that's going to be our job to determine that. And we want to look at the parts, the pieces, look at the wear patterns, put together a sequence of failure, because usually it's just a sequence of events that lead up to a failure. And that's what really made the cost class great, was that tear down of the semi-hermetic compressor.
Yeah.
And everybody, I don't care how much experience anybody had, and I even learned something every time.
Yeah, me too.
And something a little bit new, something a little bit different, something to bring up discussion and get, as you say, get that conversation going. And that's what really made that class great, those tear downs. And anytime you can get into that, anybody that's out in the field may already do a little tear down themselves on a failed compressor up in that machine room, potentially. I hope they're at least pulling the head and the valve plate off, pulling the oil pump off, shaking hands with the crankshaft. There's just a handful of things you can do just quickly to check them out. And I think that's what makes the semi-hermetic compressor what it is. And I think that reciprocating, technology is going away less and less each year, but it's still got its place in the industry for sure.
Yeah, no, and I agree. Like you're going to see, depending on the application, you're going to see semi-hermetics mostly in the larger stuff. But I've been studying all the manufacturers now, because my background was Copeland, and I've tore down a lot of them, and we've done lots together. And I see my buddy Don Gillis is there too. We've done lots of tear downs together. The biggest thing is looking inside these compressors. So, for example, if you understand how to look inside a Copeland compressor, you're going to understand how to look inside a Bitzer compressor. They're semi-hermetics. You'll understand in a Carlisle compressor or a Dorin or a Bach. One thing you need to do is understand the components inside that semi-hermetic. And a lot of people, well, I never taken a compressor apart. Well, all these big manufacturers, they make awesome compressors. Copeland makes great compressors. Bitzer makes amazing compressors. Dorin makes amazing compressors. The thing you need to do is go do some research and find out what's inside them. Like Bitzer, go to Bitzer E-Parts, and you can go and see every single component, every part number inside there. Because in Europe, they still fix the semi-hermetics. And even here in Canada, I know contractors that are replacing pistons inside Bitzer compressors, because you can access some of the parts. What you need to do, and when I worked at a contractor maybe 10 or 15 years ago, as a contractor, we had a guy that would repair Copelands. He would put new pistons in, new rods if he need to, but it's not cost effective really today. What's cost effective for the customer today is really figuring out what caused the problem, and you can replace some parts, heads, valve plates, if the compressor is still okay to run. And that's the big thing. At the end of the day, I don't stress about, is this compressor manufacturer more efficient than that? Because I heard all of it, and I've seen data from all of it. They're all these big manufacturers are close. All the efficiencies are close. At the end of the day, it's how we set up the system to make it efficient. Because you can have the most efficient compressor in there, But if it's not set up properly, you're not getting any efficiency anyway at the end of the
I've
day.
always said that about brand also, Trev. I mean, that's, or contractor grade compared to, high end, that's, it's really all about the setup and the work that we do out there in the field.
Yeah, because if you have a plug condenser, if you don't set your metering device up properly, if you don't set your floating head or floating suction up properly, there's so many different things that we can talk about. Let's dive into a little bit about air-cooled compressors, because I know you worked on a lot of that. Really, back early in the day, they didn't have pumps, right? And they didn't have
Yes.
pumps because of the low-pressure refrigerants. When we got
Yeah.
into the HFC era, then we needed pumps because it was causing massive amount of failures. So they added pumps to them. And this is one thing that I learned from doing so many teardowns is that, and I've seen so many compressors come back, air-cooled compressors with the dip tube. So in the K body, I believe it is the K body compressor, they would have a dip tube in it. And I've seen come back under warranty, failed because the dip tube was broken. That compressor would not have ran 6 months with a broken dip tube into the oil. You're telling me that there was 6 months of no oil in that compressor. But you need to be looking inside these compressors. What are some of the things that you used to teach on air-cooled compressors to help technicians out? So like the K body.
One thing about that dip tube, let's just kind of touch on that just a little bit, because and I forget the exact name of that pump. You might, if you can add that in there. It had a particular name for that air-cooled oil pump. That dip tube is put on it. It's a bushing fitting. It fits over a metal nipple, if I can say that. And then they put a little key on top of it, and that kind of puts in place. Almost every time you pull that oil pump out, if you're not careful, you will either break that tube or at least pull it off. And so we always told everybody after the oil was drained to flip over and take the bottom plate off first, because then you could see if that was a problem. Because half the time that somebody, especially in a teardown, when you had 8 or 10 stations going on, they'd be pulling them off and they'd be broken and all saying that's the problem. But just one thing to keep that in mind. And in that teardown, we always taught them to take the bottom plate off first, because there's more to see from that to an extent. Even leave the head on right now, pull the bottom plate off, take a little look-see, make sure that tube hasn't been broken, because that's when you'll really see it. And you guys that are out there in the field, you get a chance to do that, and then go ahead and undo the oil pump and and don't be careful pulling it out, and you'll break that thing. So, and I don't think that was ever meant to be a replaceable oil pump, though some may have done that. And I'm sure there was some that stuff that was done with that, but it just has to be careful. And that's the last thing put in place. They flip the compressor up and down, put the tube in on the assembly, and then put the bottom plate on. That's almost one of the last things that get that's done on the assembly of those. But it's just one of those things that I tell you can see a lot of wear in those compressors real quick if they're getting flood back or overheat.
Yeah.
And those are probably and of course overheat, and we'll talk more about that tomorrow, is not probably the number one cause of failure. Or potentially in most cases.
All compressors.
But yes, in all compressors, not just air cooled. But the air cooled compressor, a couple things a lot of people never understood about them is a lot of those the older ones had cast iron ring, or had cast pistons with rings. And then they went to those aluminum pistons and they put an oil groove in those. And so they would take these apart, and somebody would say, why doesn't that have a ring on it? Well, it wasn't meant to have a ring on it. That was a piston ring, excuse me. And so that was something you had to learn to teach these guys too. And we wanted to make sure they knew that they were serviceable. There was only a handful of things they could do, but the key thing is to understand the application and make sure that it's in an area where there's good airflow around the compressor. You're getting the amount of air you need over it. Make sure those connections and your packings don't get wore out and they don't leak. Check for your grommets and vibration on those. Those tend to be a little more shaky than some, of course, any reciprocating application is going to be more than any scroll, no matter what. But it was just the thing that there was just certain things they had to be applied correctly. And if the guy in the field wasn't familiar with this or whatever, he may condemn that compressor real easy. Maybe they, it was just a little bit of a different bird. So we wanted to make sure. So we would go over the internals on those. Most of those had 2 cylinders. We talk about the crankshaft and how that is and the amount of height that piston should reach into the cylinder. That was important to make sure they understood, because you could always tell if you had a little wear one way or the other on the bearing below or something, because one piston wouldn't go up all the way. And of course, it was always great to tear those apart and see the broken pieces. We called that ABU back in the day. You might remember Brown talking about that back. I was all broke up, it was his way of saying that, but it was pretty cool to see that. And once they understood that like any liquid refrigerant coming back was not going to be good for that compressor, they started, the light bulbs started going off more. So they were more careful with systems and service and that kind of stuff.
Yeah, no, and exactly. And one of the things is that when you need to recognize what type of compressor it is, and for air cool, for a K body, for example, both the discharge and the suction are right on the head, so it's a quick way to look at it. But always go back to that nomenclature. We talked about it about scrolls. It's no different with the semi-hermetics, any compressor manufacturer. You want to get in to understand what that compressor is designed for: refrigerant, electrical, the different parts. And that's what the model number is for. I'm going to stress this time and time again about compressors. And it's really like any component in a refrigeration system. You need to understand those model numbers, because there's so much little details in each of them. Once again, I said it time and time again. I didn't do that back when I was in the field, because I didn't know there was that much information. And that can totally help you maybe find the problem out. Because I've done it before, where I picked up a compressor from a wholesaler, drove an hour and a half, go to put it in and look at the nomenclature and find out it's the wrong voltage. Now that's not that awesome when you do that, but it happens. So when you understand the nomenclature, it totally helps you out.
Trevor, nomenclature is really a huge deal. Would it be much trouble to pull up a semi-hermetic model number?
No,
by chance?
Yeah, we can
or not. I can give you a brief description of what they are to an extent.
Yeah.
The first series of digits is the mechanicals. The set, and then separated by a dash will be another 3 set of digits, and that's the electrical data. And then the last set of digits, last 3 set of digits, will be what's called that bill of material. And we talked a little bit about that yesterday. But that bill of material is how that OEM wants the compressor built. Does he want this? Does he want that? Does he, whatever the circumstances are for each application can be different. But when you get into that nomenclature and understanding the first set of digits, the first digit's going to be the body, or which is the casting, more or less. So, you said K body, when as soon as you seen that K in a compressor, you knew that was an air cooled compressor. Now there was a handful of L's and M's back in the day that were also air cooled, if I recollect correctly. And then when you got into larger ones, then they changed the casting somewhat. And but they actually had the same casting. They would depend on where they bolted the valve at. They just put a cover over it. But you could, that's that nomenclature is just so important. And when you look at the electrical data, the first digit in there is going to tell you the voltage. The second digit's going to tell you let's see. I have to reach back here.
It's all good.
You the voltage.
They make it easy for you today.
I think is the type of protector.
Mm-hmm. And
the third digit is the phase.
Yeah.
Okay. I have to reach back there. I was hoping you could pull it up.
TFE or something.
Jog my memory,
but every compressor manufacturer is going to have those. And like Copeland makes it super easy with Copeland Mobile. You just go to Copeland Mobile and you look that stuff up. If you don't have that app, you need to download it right now. And like I said yesterday, you need the Danfoss app. You need to download the Bitzer app to get all their documents. You need Copeland Mobile for sure. They did a great job over the years developing that. And these are tools that you need to have in your tool. Yes, it's on your phone. This is, you can't see it. This is a service tool using your phone. And there's so much to really know. You need to dive into that compressor you're working on. So if it is the Copeland 3D, 40, 60, if it's a Bitzer 3-cylinder, 4-cylinder, 6-cylinder, you need to find out those manuals, get into those manuals. I got a podcast releasing tomorrow on the Bitzer service guide. Like maybe you work strictly on Copeland, or you just work on Carlisle's or whoever. You got to read the other manufacturers' manuals. There's so many good tips and tricks in there to understand that specific compressor, that specific semi-hermetic. Because if you don't, it's just going to take you longer to learn, because I've seen things that I've learned from Bitzer that I could apply to Copeland, and same thing from Copeland to Bitzer in their manuals. And the more you read on this stuff, the more it's going to get easier for you as a technician to troubleshoot. One thing that we didn't talk about, so some of the air cool has oil pumps, but some also have something called a Flinger Feed. I think that's what Copeland calls them. Bitzer call it a Slinger Feed. So it depends on the refrigerant in there for Copeland anyway, and then the size of compressor as well. But now when we see in CO2 compressors, semi-hermetic compressors, you're going to see both Slinger or Flinger feeds as well as pumps, depending on how big they get. And you'll see this with all the different compressor manufacturers. I was doing a CO2 Monday this week with Dorin, and great guy. And same thing, they have a splasher feed or a Slinger feed, whatever you want to call it, as well as pumps, depending on how big you get those compressors. And it's sometimes an option. So you really got to understand these semi-hermetics that you're working on. So let's talk a little bit about larger semi-hermetics and the things that you should be looking into if you do run into an issue, because we know the larger you get, I think it's over 3 horsepower, you get into refrigerant cool. Air cool is not going to be sufficient, like we talked about. So you'll get into refrigerant cool. And really, what is refrigerant cooled, Bob?
Well, I always think of refrigerant cool as that you rely on the mass flow and velocity of the refrigerant coming back to the compressor, and it comes back in typically either atop the end bell or on the end, depending on the manufacturer of the model to an extent. And so that gas is it will pass over the motor first. And generally the motor compartment will be separated from not in every case and not in every manufacturer, but separated from the crankcase compartment. But as the gas comes back, it has to pass over that motor. And we always think about motor cooling as being very, very important. And we didn't get to this yesterday for some reason or another, Trav. I'm going to hit it a little bit now. That you're cooling the motor as that gas comes back. And if there's a little saturation in that gas, I don't want to say a complete flood back, the heat of the motor typically is going to probably be able to flash that off until the motor starts to cool off. So, but the importance, we think about keeping the motor cool and not going off on protector. That's what we always think in our brain or in our mind when we're out in the service. And in reality, it's really all about the oil. The temperature of the oil, the condition of the oil. That we always wanted to stress that when we were talking, especially these larger compressors that were thousands of dollars to replace. It's really all about the oil at the end of the day. And if the oil's not returning, then I'm going to have problems. Remember, I should have a little oil saturated with the refrigerant, and that was what in the old days, old mineral oil and the old CFC refrigerants were very compatible. They loved each other. As we went into different refrigerants and went into different oils, that compatibility had to be engineered in and had to be kind of taken up. But it's that temperature of that oil is just really huge, because if it starts to degrade, starts to get above a given point, it's going to create some issues. You're going to the oil's going to break down. It literally will cake or bake sometimes in some surfaces of the compressor we see in teardowns. And but we always try to stress that it's really about the oil. And people think of overheat, oh gosh, the old compressor got overheated, but what caused that? Is that a high return gas temperature? Was there a head cooling fan like you're showing here on this compressor on the screen not working or not coming on or not turning fast enough? I think when we say 1,000 CFM with that, I think, Trev, is that right? So. We wanted to put across that, but I think it's really all about the oil to an extent. I'm glad you brought this compressor up, because there's an operating dude here. So
yeah. No, but it's really important to understand that there's a lot of things and there's a lot of factors that you have to understand in the system. Like we talked about that mass flow coming back. If your system is overheating, mass flow is one of the most important things. And as a technician, we don't think of mass flow. We're not trained like that in school. I wasn't. And I only really started learning this after working for a compressor manufacturer. But it's one of the most important things, because how that gas moves through the system means how your system is running. And that's where we got newer technologies like VFDs, digital compressors, unloaders. Unloaders been around for decades. But these technologies that really are going to change that mass flow, or adjust it, like VFDs. And you need to understand that when you adjust something or set something up, you want to know what's going on in the pipe, right? Or you want to kind of think what's going on. And how do you figure what's going on? You use your tools. You use temperature probe, find out what the temperature are. Why is it this temperature? Check the pressures, understand the pressures. You need to plot that stuff on performance charts or operation envelopes. It's so important to do that. I do this when I'm training on Bitzers, or when I'm training with Carlisle, or whatever compressors it is, or Copelands. You need to understand what the limitation of that compressor is. And it doesn't matter what refrigerant, it doesn't matter what application. You need to stay inside the envelope while it's running at all times. And when it gets outside of the envelope, it's going to start to affect the performance. It's going to affect the compressor itself. But I've seen it in, even yesterday, yesterday I did this call with Duran, and he showed me 2 hours of consistent flood back in the field, a whole rack, and they fixed the problem, and the compressors are still running. And so if you can resolve the issue that's happening, your customer may get a longer life out of that compressor. Compressors from these manufacturers don't just fail. Bitzer compressors don't just fail. Copelands don't just fail. Box don't just fail. What happens is that either we are the issue, we cause the failure, or the customer caused the failure most of the time. Because no maintenance, no service, improperly installed. That's the biggest failures. Yes, there are times manufacturers send out compressors that gets through their quality control that there's an issue. Or it gets to the other manufacturer, because compressor manufacturers aren't building the equipment most of the time. They send it to a manufacturer and they build the equipment. And then sometimes at that manufacturer, something happens, wrong wiring, wrong voltage, it could be lots of different things. But always the compressor manufacturer got the bad rap. I've seen it and I heard it. It's important to understand that when we're talking about semi-hermetics, they work the same. So if you're working, like I said earlier, if you're working on a Copeland, a Bitzer, a Carlisle, they're going to be working the same. So take the time to learn the intricacies of each one. Get the manual for it. Find out. Once again, get that Bitzer service guide. It's 90-some pages. This is a service guide. There's a lot of stuff that you don't need to read in there, but there's so many great tips that are different in Copeland. For example, what does Copeland recommend to the discharge temperature on a semi-hermetic like this? Bob, do you remember?
Well, we'd always remember 6 inches out. And we'd always say, and this came from the old mineral oil days to an extent, but we would always say a maximum of 225 degrees, 6 inches out. There might have been a little more leeway with POE potentially, but we never said that out loud just to kind of get people thinking about that. But we did find that so many people never measured discharge temperature. It wasn't part of the thing. They would already set a set of gauges on. They would do superheat, subcooling, around parts of the system. But a lot of folks just never considered discharge temperature as part of the routine, if that makes sense. And it was one thing we always pushed. And I know Bitzer always pushed when we did their screw classes years ago, when they made screws for us back in the day and painted them black. But, discharge temperature is just a real quick indicator of what's going on internally in them cylinders. And they typically, I think the way the labs determined was that they can tear a compressor apart, put sensors in there. We don't do that in the field, but they determined that you lost somewhere between 50 and 75 degrees between the discharge valve and 6 inches out. So that's where they came up with that 225 number, going on the high end of the 75. And so if you were above 225, you were above 300 in the compressor. And the hottest part of that compressor is the suction, and the discharge valves, I should say. And if you're overheating there, guess what's happened to the oil there? It's disappearing. And so that was really an eye opener for a lot of folks as we started doing these classes, and opening for me too. That was just one part of what I thought about at one point either, especially if you were working on the residential world. how do you get into that machine? You know, and that might not be as important there, but when I've got a machine like I'm seeing in front of me here, this 4-cylinder machine here, that's a much more complicated, much more expensive piece of equipment, and it's needed to keep that food in the supermarket cool, you know, so
Yeah.
refrigerated. So yeah, much more important. Hey, one thing I was thinking about, when you talk about mass flow, Trav, I just, as you were talking, you know, when we talk about high temperature, you almost always have a pretty good mass flow. Generally, as I start going down in temperature application, what happens to our suction pressure, guys? Goes down, doesn't it? And so mass flow starts to reduce. And when I start getting into them low temperature applications, I typically can't get enough mass flow across the compressor motor or that oil down in that section coming back. So they do add something like liquid injection. In scrolls, they have vapor injection, but you know, they do those. I don't see I think I see an injector on this one. I'm going to say maybe it's a medium temperature compressor. Well, it's got to be low with the head cooling fan, I think. But there is a head cooler. There's a little radiator underneath that oil cooler. We call that an oil cooler underneath that. But you know, there's all kinds of ways that they wanted to take care of things, and from an engineering standpoint, they did. If they added liquid injection to that compressor, it was because it needed it, and you had to make sure it was running right. Another part of your checkpoints in those low temp applications, you know, to make sure that was feeding correctly and the metering device wasn't plugged. And basically, you're bringing liquid to it, and you're running it through a little metering device, so you're introducing a little vapor into that. You're really going to mostly vapor as you leave that machine or that thing, but you know, it's just mass flow is just so important. But remember, as you drop in temperature application, it also goes down. And so they make arrangements for that.
Yeah, exactly. And like I said earlier, if you put a drive on it and you start to slow down the speed of that motor, it's going to slow the mass flow. It doesn't matter what application is, you're slowing down the mass flow. And it's important to do this discharge temperature check on really all compressors. You had a good point. Residential is a tough one to do to get in, but if you can take in, the more points you can take, it doesn't matter what system, the more temperature and pressure points you can get. And even if you don't understand the application or you don't understand how to troubleshoot it, if you have enough of the correct information, superheat, subcooling, discharge, suction, temperatures, and you can give that to someone who understands refrigeration a bit more, they can help guide you on what to look for. But you need to get as many temperature and pressure checks as possible, because that's when you can start looking inside the system. Now, if I have the right amount of, and I can do this with CO2, which is good because you have so many pressure and temperature, I can see inside the pipe. Is it vapor? Is it liquid? Is it saturated? And you plot that on either in the enthalpy diagrams or understand where you're at in that system by the pressure or the temperature. And it comes with the experience. For Bitzers, for an example, they don't say 6 inches. If you go into that service guide, they're going to say 4 inches and 250 degrees. You know, so these are the little tips that you can understand from the different compressor manufacturers. Or Copeland, I think Copeland recommends 12 hours to have the oil heater on, right, for their compressors. Where Bitzer has actually a temperature, I can't remember what it is, if it's 95 degrees above ambient before they want you to start that compressor. Why do the compressor manufacturers want you to heat the oil before you start it up?
Well, viscosity, it'd probably be a big point. You need to, you know, the oil as it gets colder becomes thicker. And you definitely want to keep that up. And then if you're in an operating system, potential of liquid refrigerant condensing in there could be your other factor for sure. You know, if it's a brand new compressor, you're probably not going to have that. But I still would recommend getting it on because you just don't know. So you want to make sure you got good viscosity with that. But yeah, any liquid refrigerant in that compressor, when it goes to start in the crankcase, that's going to be very bad very quickly generally. And there is a little vent valve, and they try to relieve pressure, and there's some things. But if that thing is, if you look at that sight glass, I see you got the oil level on that thing there. If you look at that sight glass and it looks like the oil, it's full. It looks like it's above the glass. There's half a chance that you have some liquid refrigerant in there. And I would want to make sure that crankcase heater has been energized and on before I start that compressor. And the sight glass and the oil level are very, very important too. I noticed, I didn't know if you were going to hit that next, Trav, or not, but you know, just since I see it up there, the oil level should be somewhere in that sight glass generally. And I think almost everybody says something like that. if you're familiar with your system, you want to trend that data, because that will tell you a lot about oil return. It will tell you about how, if the fill device is working correctly. If you're trending that information, you're familiar with your equipment. And a lot of times we do go work on the same stores and the same things. And that information, as we trend that data, as Trevor was talking about with service and all the points, the more you know, the better off you'll be. So
100%. And this is why you need to have a journal. You need a log, everything that you're doing. The technicians, and I did some of it, but I didn't do enough of it when I was in the field. You got to be logging, writing down what you're doing to figure out the next time. Because if you're just going and doing stuff and then just shooting by the hip all the time and you don't have the proper processes, it's going to take you a lot longer to learn refrigeration. I'll tell you right now, I've done it. I've done all the different ways, and I see the differences in the technicians. Those technicians that get their processes down on how to check compressors are way ahead of the game. And they're servicing compressors better. They're understanding and fixing problems quicker and faster when they have the correct process. The biggest thing is learning about that specific compressor that you're working on, those little tips and tricks like I talk about. For example, start stops. It's a big thing. It's a big thing. So once again, I was just on a training with a compressor CO2 training with Durin. They do 200,000 start stops to see how it affects their compressor before they send it out. Before they go to qualification. 200,000. So 2 seconds on, 4 seconds off. Bitzer does this. Copeland does this. All the big manufacturers, they all do this and test their compressors. What is the biggest thing when you start seeing compressors short cycling, Bob?
I mean, what's causing them, or what damage it
could do?
I'm sorry?
What damage it could do?
What damage you can do? Well, every time you're starting this thing, you're energizing the motor without having mass flow, and so you potentially can have some issues with that. So I think Copeland said 6 cycles an hour, at one point now. That's tough if you're a refrigeration guy sitting up at the supermarket, no question in some cases. But when you're starting and stopping this thing, you're energizing the motor. You're not having the cooling that you need to that motor. You're not potentially having the cooling you need to the oil. When it does it, when you just now get going to it and then it shuts off, then potentially floodback could be potential, or condensing of refrigerant in there. You just short cycling is not, and that doesn't, the mechanical wear on the compressor is bad, but think of what it's doing to your contactor. That was always a biggie that you wanted to kind of stress, that we always wanted to kind of stress, was that, the wear on that contactor is going to create some issues, and eventually maybe some voltage drops and more excessive pitting. And then you just bang into another problem on top of that there. Something else we should add though, Trev, to that question?
No, I think that's great. You need to understand that, because that stator, it's heated up every time, and then it continues to get warmer and warmer. And we talked about it yesterday in the scrolls, like when you have advanced scroll temperature protection, when that compressor is running without any mass flow coming down to cool it, you're just heating up the stator more, heating up the rotor. And when you're short cycling, the same type of things happen. You don't have that cool gas coming back to cool the motor. The next point we got here is suction temperature. It's pretty important on refrigerant cool compressors like these semi-hermetics. This is something you need to check all the time as well. All the time. Because it tells you so much. Important.
Do you have suction pressure also eventually with that also,
yeah.
Jeff? Got the compressor in it?
Yeah, suction pressure and suction and discharge pressure. What are some of the things you can do with suction and discharge pressure?
Well, I would think of compression ratio would be my first thought. And not everybody thinks that that's something you have to do, and you don't necessarily have to maybe do that every time. But once again, the more information, the better. But your performance and what's going on, and when you run these charts, you want to know what your suction pressure is, your discharge pressure, and your type of refrigerant, and again, of course, the model number of the compressor. But when I'm looking at those from a standpoint, the first thing I think is like I said, with the compression ratio. And when you get into low temperature, that could be 8 or 10 to 1. That's not a big deal. But I would want those numbers to plot capacity. I think that would be important from my perspective.
Yeah, and when you get into those performance charts, those envelopes, it's going to tell you so much. You got to get into the different manufacturers' information. So, like we said, Copa Mobile already, you can get into that performance chart. Bob just talked about compression ratio, so important, something that I never even thought of. I might have seen it when I was in school a little bit, but it's something that I never used to my advantage as a technician in the field. This is where you can use it and plot it, just like Bob said, you can plot it. And how do you check compression ratio, Bob?
Well, you want to have your suction pressure, your discharge pressure. You want to add atmospheric pressure. We always just rounded it up to 15, and then divided the smaller number into the bigger number.
Yeah.
And is there a new thought on that now with anything else, Trev?
No, you just do that and kind of gives you an idea. For me, it means a lot because even with semi-hermetics, if you have low compression ratio, it can be an issue. If you have high compression ratio, it can be an issue. We know high compression ratio, compressors working harder and it's generating more heat. With low compression ratio, well, you're not moving the gas that you need to move. And if it's too low, then you're going to have no efficiency, potentially breaking reeds in the compressor. It doesn't matter the compressor manufacturer, because if you have super low compression ratio, it's an issue as well. So this is why compression ratio is important. And you all have to get to either Copeland Mobile OPI, you got to get on the Bitzer software. That's where you can find out all the operation envelope. For Carlisle's, it's called the Carwin software. You got to get onto if you're working on Carlisle's. For Tecumseh, you got to get on the, I think it's Tech Tools. All this information's out there. So if you want to see what your compressor, what your mass flow is, what the amps of that compressor should be running, you got to, it's at your fingertips. So it's so important to take the time to look at this. And this is why it's also important to read other manufacturers' literature, because they have experts writing out these technical documents. And one technical document from one manufacturer and the way they think and the way they write it up is going to be different than the other manufacturer's technical expert. Both very smart people, but you may pick up, once again, one or two different things, the way they write. And when you get out to the European information, man, I learned so much from reading all the European documents from Bitzer, from Copeland, from Bach. I couldn't believe, because I never even heard of Bach until I met some of their team there. But their manuals are amazing. Step by step, I learned so much. I'm like, wow, it just makes more sense. The more you read, the better you're going to get. Gonna get better at semi-hermetics. So, talked about compression ratio. We still got this up here. Like cylinder temperature. How many people do cylinder temperature checks? Because I didn't in the field. That was a long time ago. But how many of you do this? Even when I worked for the manufacturer, they didn't really talk about checking cylinder temperature. I didn't talk about it that much because it wasn't something that I've read in the literature a lot. You go into other compressor manufacturers, they say if you have a big cylinder temperature difference, there's probably an issue. Does that make sense, Bob?
Yes, between the two cylinders is what you're meeting. Because in this example you're looking at that deck or head to the what would be my left-hand side, I guess, and you got your arrows pointing to it. There's two cylinders in there, and they work independently. One's up, while the other one's down. And if you have a bit of a blown gasket, you have a bad reed. That's a discus, I think, but still the same concept. You could see a difference there, and from one head to another or one deck to another could also be an indicator. Also, you're measuring on just that side. Don't forget to get the other side too.
Yeah, exactly. And these are the little tips and tricks that you want to go above and beyond what you used to do, because that more information is going to tell you something, and over time you're going to see patterns. And the more patterns you can see, the easier your job is going to be. The easier it's going to be troubleshooting. It doesn't matter if you're in residential, light commercial, industrial. When you start recognizing patterns on the compressors, it's going to be a game changer, because now you can take that information and you can, you use it on this site, on this application, on this store, and it'll make you better understanding the data. And this is what I liked about Supermarket, because I could go in and see a lot of data in one place, where now if you're working on a packaged system, you need to go collect that data. You need to go get the suctions, and you still need to do it in the supermarkets or CO2 applications, because this is where guys' fault as well is, and I've seen it, is where they're relying on the controller that is electronics, that electronics can fail. You still need to go get and put your gauges on the compressors. Like, for example, go ahead, Bob.
No, I was going to say measure temperatures and pressures and all that.
For sure.
They don't necessarily can correspond.
Because the way I did it before is, like, I would just take on a rack, I would take the suction pressure and discharge pressure, which on the header, not on every compressor, just on the header, and be like, okay, the system's running at 55 and 250, whatever, PSI, because I know some people deal in bar here. But that doesn't mean that compressor, one of 5 compressors is running on that. They could have a blown cylinder, just like this. And you can't even tell by just reading off the microthermal, Danfoss, or E2, whatever. And this is why it's important, as a technicians, we're detectives. We got to go in and investigate what caused that. What caused that?
Well, it's really kind of funny. We were talking. Let me hit this real quick, just because we had a bit of discussion before we all started today. Discharge temperature, as we mentioned earlier, was very important. But Trevor, what would be important of discharge superheat?
Yeah. That's something that I never talked about at Copeland in North America here. It was something that you wouldn't find in material until I was doing trainings and people were working on Bitzer and telling me, okay, what about what about discharge superheat? I'm like, what is discharge superheat? That's something I have never checked before. And this is me training on another manufacturer. And then I dive into it a little bit more and then find out that it's something important to check. Doesn't matter what compressor manufacturer. If you have really low discharge superheat, and Bitzer has calculations, I highly recommend go and looking them up. But if you have really low discharge superheat, you could actually condense that gas in the compressor. And where it really clicked for me, I was doing a training for a contractor years ago, and they were like, Trevor, I have this unit, and I'm pretty sure it was a Lieber unit, and it might have been Carlisle's in there. I can't remember. I don't think it was the Scrolls yet, but he said, Trevor, we lost compressors from floodback or liquid oil dilution, but I got superheat. Have you ever heard of ghost superheat? So I go back to engineers and people tell me, no, there's no such thing as ghost superheat. If it's superheat, that means there's no refrigerant. There's no refrigerant in the gas. But if you have low discharge superheat, you could be diluting or condensing that refrigerant in the compressor, and that's how you're getting lubrication issues. So, and we really see it, and it really came into fruition for me is when I started learning about CO2. Even though you have 20 degrees superheat or 10K, 18 degrees superheat with CO2 on low temp application, you're still having oil dilution issues. And bam, right there at that point, depending on the refrigerant, even though you have superheat, you still could be causing wear on the compressor, right? Because CO2 you need for the medium temp, you need, depending on the compressor manufacturer and the application, there's a lot of variables, but you need to have 10K or 18 degrees Fahrenheit for low temp, 20K, 36 degrees Fahrenheit on a CO2 compressor. So these are the little tips and tricks you need to understand. And now with all these new refrigerants, these new A2Ls, R290, all these different refrigerant, you need to check what the manufacturer recommends. So did they still say, oh, well, you can go to 5 degrees superheat and it'll be okay? No, you need to find out specifically what that compressor tested, because they're testing these compressors. They are putting them through the test, all these manufacturers. And I've seen it personally. I've heard about it, watched videos on it. These manufacturers are not taking it easy on their compressor before they release them. And if your compressor is failing after 3 weeks, 3 months, 3 years even, that's usually something that we did. Usually. There is a small percentage because of the manufacturer of the equipment, but in the 90% is what we did or the customer did, if that makes sense. I put fan RPM up there. I don't think that's right. When I built this, I did this slide real quick a week or two ago, but probably more of a CFM that should be.
CFM.
But it's something else you should check. Is the right blade on there? Because this is not only a refrigerant cooled compressor, this is an air cooled compressor as well. And some compressor manufacturers will have water cooled heads. You know, and they're not using the fans, they're using water cooled heads. So there's all these different dynamics on these different semi-hermetic compressors. And it's important to understand that stuff. And getting in and learning about them, taking apart the compressors. And something I learned yesterday, Bob, is that I've always said, you know, and Copeland says, you know, if you have a failed semi-hermetic, inspect it. You know, pull the heads off, look inside it, but not all manufacturers do that. And I don't even know if Copeland still does that. And I don't know if they change it, because some manufacturers say, well, if it failed within the warranty period, we want to expand. Give us as much information as you know, if you have pressures, temperatures, or whatever, but we want to inspect it, because the way they inspect the compressor is different than a technician in the field inspect it. They measure everything. So as they go to take off the bolts, they'll measure the torque on how it comes off. Was that the right torque rating when they peel off? And when they start, and you can see behind me, like right here, they'll test the torque on the backing plates and whatever it is. So there's a specific process. For me, I would say tear it apart, but you always want to follow up with your wholesaler or the manufacturer of the equipment to see if it's okay, because that's how you learn. If it's out of warranty, get into it, tear it apart. That's how you're learning. Definitely look inside these compressors, because you're not going to learn if you don't understand every component inside there. And we didn't even dive into all the components. You said one, the vent valve, which is in between these two cylinder heads. What else is inside the semi-hermetics, the larger ones, 3 and 4, 6D?
They'll have, they got multi-decks, and so they'll have multi-valves, and they do use a larger vent valve in some of those.
Yeah, sometimes two.
Not exactly sure where you're going with that, but you know, that vent valve and keeping that pressure in that crankcase down so we keep oil going up to the pump is very important. So
yeah, they got an oil check valve
you
in
wanted
there.
to hit on that?
Yeah, an oil check valve in there. So
yes. Okay.
A free floating check valve inside these compressors. So
on the dividing wall.
You need pressure to come in to open that. So now, like just like you said, if I got more pressure in that crank and where the pistons are, there might not be that oil flow that you need. And these are the little tips and tricks that you need to understand. You need to check blow by. I don't know if I put blow by in that one. Let me just pull that back up. But you need to do a blow by check.
You did. I thought you had blow by.
Oh yeah,
blow by test.
You need to do a blow by test. Do you remember how to do that test, Bob?
Why don't you refresh my memory, big guy?
Yeah. So exactly, to do a blow by test, you need to check always that the body of the compressor and for Copeland's, the body of the compressor and the crank where the pistons are two separate pressures. They're different. And what you need to do is check the pressure from here to here.
There. Okay, that's right.
Then you pump that compressor down. So you loosen the packing first. You see how I've loosened the packing here in the district? You loosen the packing first. Then you start to slowly close in your suction, and you watch your gauges start to drop down. If this pressure here, your crank pressure, ever gets higher, that means that vent valve's overcome and you're having blow by. And blow by could mean the compressor's damaged or another component's damaged, kind of like this oil pot could be damaged, right? So it's not necessarily the compressor damage. Only way to find this stuff out is looking inside it.
Well, that's and I had forgotten that. Yeah, thank you for refreshing my memory. But that is something we talked about being very important, because you just don't see that, and there's not indications of that unless you do cylinder temperature checks or some things like that. But it is really important, and you just don't know that, and we can't always access that. But we always put fittings on everything when we needed it. If we wanted to get into that crankcase, take where they filled it at, put a fitting in there. I know some OEMs do that ahead of time, where they do the final oil fill. They'll put a 1/4-inch square MIP fitting in there, and that way you can get that true crankcase pressure. really important to do. Thanks for refreshing my memory.
Yeah.
That's one thing you were talking about. We talked about yesterday. You just mentioned there about in warranty and out of warranty. Now, depending on what it is and how you want to do it. If you're out of warranty, I know Copeland, if you'll pay a couple extra bucks for shipping and maybe a slight diagnostic fee, but if you really need to know what caused that failure in the compressor, they will take that. You'll have to arrange that with your full line authorized wholesaler, but they'll arrange for you to get that report. Like I say, you're going to pay a couple extra bucks for it. But if you've changed one compressor after another and not paid attention or not looked at the system, then potentially that's a good way to see, because they will tell you about that. I think the turnaround time, depending on where you're at, somewhere a couple of 2 to 4 weeks. But I won't say it was immediate.
If it's 2 or 4 weeks, they do an amazing job, because it definitely wasn't that. It's way.
And guys, you can send them in when they bring them compressors back. The first thing they do is take a little visual inspection, note the startup date, note all the equipment stuff they can get. First thing they do is put it on a dry air board. Let's put some juice to this thing. Let's see if this thing will start, run, and pump. And if it does, then there's less that they may end up doing to a teardown, without a question. From that point there on, if they are going to go further, they'll drain the oil, evaluate it, and send it in for testing, whatever they want to do. And they have a procedure, like Trevor said. They as you're unbolting everything, they're checking that torque. Now, these guys are pretty good at this over here in Rushville. Anyways, I know that they were very enlightened to that. And there was a group of about 4 guys. That's all they did all day. We'd go over there a couple of weeks and work with them in the summer sometimes, Trev, in my early years. And these guys hustled. They worked my butt off. I was a little younger then too.
Experts like Steve Wagner. Hopefully he's still there, man. 40 years tearing down semi-hermetics, and he taught me so much. And I haven't even met him in person, but he taught me so many different things. And for a while, he was sending me images where compressors were coming back after 3 weeks, and there's nothing wrong with the compressors. And there were so many times when I worked at the manufacturer that the compressors come back and we could start them right up. There was nothing wrong with this $10,000 compressor. And it's just, this is what you need. You got to put the hard work in. You got to learn about these little different things. I got something down there.
Steve developed those processes, Trev. Steve developed those processes, the procedures. You know what I'm saying? That's the standards, if you want to use that name. Yeah, Steve is a great guy. We go work every summer. We went over and hung out with him.
Yeah, and this is how you learn it. You gotta want to learn as well. That's the big thing. You want to learn, because like I got vibration tests down here, and people are probably, what's a vibration test? How do I do a vibration test? But you can test a vibration on it. How do you think you could do that, Bob? You may have never done it before, because I didn't do it in the field because I didn't know until I worked with different manufacturers, asked some questions, been at a vibration analysis test where they have big machines, but as a technician, you don't need big machines. What's one way that
that would be the old feely, touchy way, probably with a screwdriver or you're not going to grab that discharge line with your hand. I hope you don't.
But exactly, you could take a little pocket screwdriver and start going down along here and see if it starts to bounce. And if it starts bouncing real hard, you may have some sort of pulsation, right? Or maybe you don't have the proper discharge muffler in here, or what's it called again? It's a
isolator.
So they'll reduce the pulsation.
Isolator there, just on the other side's an isolator. Yeah.
No, not that one, but actually there's something that goes in some compressors, depending on the refrigerant, depending on the application, where you'll put a little. It's like a steel. It's not a gasket, but it got a hole in it.
It's like a ring with a hole in it. Yeah. I forget the name too. I know.
But I think it's for, is it for pulsation maybe? I'll have to look it up.
Yeah, it's to minimize pulsations, Trev, I do believe, if I remember.
But there's so many different things that you want to understand, because if that's not in there, maybe that's causing the problem, and that's the issue, because cracked lines do happen. We're at 11 o'clock. I love this. Like, so much information, and we just hitting the tip of the iceberg, right? You guys need to get out there and you got to read these manuals. I know it's hard. You got to go take all these pressure. Look at all these. When I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll remove like the fan RPM, because that one probably shouldn't be up there. But you should see if it's the right blade. They should be running every time, because if you don't have that air over it, you're heating over that compressor. Net oil pressure, we didn't talk about that. But why don't you review net oil pressure if you remember it, Bob?
I'm sorry, one more time. I was
That
looking at the
oil pressure, how
questions.
do you check it on a semi-hermetic?
Well, you're going to go inlet and or crankcase and outlet.
Yeah.
And those are in the differential between the two is going to be your oil pressure.
Yeah.
But,
So
that is a very important part, because as we start dropping in oil pressure, getting that oil all the way back, especially on a larger machine, shoving it all the way down that crankshaft to that end bearing into the last few journals of the rods, can be very, very important. But yeah, inlet crankcase pressure and outlet pressure.
yeah. And if
Or,
you have
or
your,
inlet pressure and outlet pressure, depending on where your fittings are at.
and if you have your gauges set up properly, because a lot of people do it from the suction, as you can see, there's something on here. It's a difference. There's a difference in pressure from here to here. And if you're doing proper testing, if you're testing for flood back, you actually need to do it from here to here. This is from the pump to here where I got the two lines. And you can actually see when you're flooding back. It's going to show you in your gauges if you're actually flooding back. What's the best way to see if you're flooding back, Bob? What's one thing you would do to see?
Well, we always talked about superheat, and I think that's important.
That's the number one thing.
You get oil dilution. Look, see what's going on in your sight glass. If
There you
some
go.
flood back going on, you're going to see foam in there.
Yes.
That's almost a true indicator too. And like you say, maybe you have a few degrees for superheat.
Yeah.
Maybe the motor's already cooled. There's lots of little things, but yeah, little foaming in a sight glass is one thing that's really, really important to check and see.
So check
and
your
the level,
superheat.
of course, too. But
Yeah. So many things to talk about. So many, there's so many great things. So we're going to be doing one more session. We're going to be diving into compressor failures, issues, system troubleshooting. We went through some of the stuff there. We're going to get to a couple of these questions here. We often hear about maximum return gas temperature for certain compressors and application. How do you figure out the correct return gas temperature? This is easy. You go into Copeland Mobile and you input it into the troubleshooting guide or the diagnostics tools. You go into the bits or software, you select that specific compressor and you put your information in there, and it's going to tell you if you're above or below that return gas temperature. You'll see that there's these AHRI standards that compressor manufacturers have to go abide by. But I think it's 65 degrees.
65
that's the standard.
is what they test at. I remember that
that's
number
ancient.
now for some reason.
That's ancient. There's no compressors running at 65 degrees. You know what I mean?
Return
Maybe there
gas
is, but I'm just saying, like, you want to have cooler gas coming back. You know what I mean? For efficiency. And then we got another one in Copeland Mobile. Can you look at suction temperature and come up with the corresponding amperage figure? Well, you need not just suction temperature. You need the suction pressure, suction discharge pressure, and voltage.
Yeah.
And then you can figure out what it is. So plus or minus, depending on the compressor manufacturer, depending on the compressor, I think it's around 10 plus or minus for that. For a great question. But you got to get into the apps of these compressor manufacturers. You got to be using that, utilizing them. You're going to get better when you're doing that stuff. That's it. You're going to get better. Bob, how can people find out more about you, about your company, and learn more about HVAC specialties?
Okay, no worries. I don't necessarily have a website per se. My company is HVAC Specialties. I'm into training here in Southwest Florida. I do still stay involved with the national stuff with NATE and instructor workshops and some other various things, but I also am available for some consulting potentially or certification. I've been very big and very involved with the industry certifications through NATE and RSES back in the early days, and everything today with the new refrigerants. There's more to do with that, but yeah, you can reach me at Bob HVAC, the number 1 at me.com. I always capitalize the B on Bob, but I don't think that's actually necessary. But
awesome. So definitely reach out. We're here to help. We want to help you out there. We want you to get better. We want you to grow your knowledge. Invest in yourself. Start investing in yourself. 2023 just started. The more you invest in yourself, 2024 is going to be even better.
Yeah. Even if someone has a question, just shoot me an email. Remind me where we met, if you don't mind, and whether it's this or whatever it may end up being. And I still stay in touch with a handful of people I used to see back doing the classes. And of course, some of the wholesalers also too. It's nice to develop these relationships around the industry And we're all helping each other, like Trevor said. If you're a lone wolf, you're probably in the wrong trade. So.
Awesome, Bob. Thank you, everyone. We'll see you at the next session. Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button, because when you do click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.